In this video, we're going to talk about the key concept of string manipulation, and that is regular expressions. Regular expressions, or regexes, are strings that signify patterns that text data is going to match. So before we introduce this idea of email addresses or phone numbers, those are general examples of patterns of text where the text follows a certain kind of system, a certain design that you want to match in a given string. But you can't match the string exactly because you may not know what it looks like in advance. Now, before we use that regular expression E, and I described it as a regular expression, but I said it's a simple one. The beauty of the stringer system is that all of the functions that we described before all work with regular expressions patterns, and not just a specific string, okay, not just the hard-coded strings. So we're going to have to talk about these regular expressions so that we can know how to tell them to the stringer functions so that we can actually process this textual data. Now, it's helpful to think of regular expressions as code, almost like a different programming language that's being interpreted by its own interpreter, the so-called regex engine. And there's a really good reference for this if you want to learn more, and that is this book, Mastering Regular Expressions. So I encourage you, if you want to learn more about regular expressions, to get that book. You can get an e-version, and it's very readable. Okay. One of the things that you should know about regular expressions, as I said, they're kind of like a different programming language. That language is more or less the same across different languages that you're going to engage with as a data scientist. So it generally won't matter if you're using Python or Julia or the shell or some other language. Generally speaking, these regular expressions are going to be the same. So the regular expressions that we learn here are going to be the same whether we're using R or Python or Julia, with very, very minor modifications. Okay? So let's get into it. Look at this sentence. Bill bested Bob. So Bill bested Bob, str extract all B. That B there is a regular expression, but notice that it did not match the B of Bill. What's going on here is that B is communicating match the literal character B in the sense of lowercase b, okay? Not including the uppercase b, okay? Regex engines are almost always case sensitive by default, okay? So when you say match lowercase b, it's going to match only the lowercase b's, not the uppercase b, and you're gonna have to do something to make it not case sensitive, okay? In writing, kind of because of this, in writing, it can be difficult to, or at least classically difficult, to kind of communicate the regular expression in a sense that's distinct from the surrounding text that is around it. Now this is somewhat alleviated. So for example, here I had a B kind of in quotes, and notice that it's like in this syntax highlighted blue kind of font, okay? That ability to express something in that blue font makes it easier for me to communicate to you what the regular expression is. But in the past, this was actually much more challenging, where we wouldn't have the ability to kind of mess around with fonts and so on. And so there were different ways to write it. It was common in those cases to put forward slashes around the regular expression. So the regular expression would be just the B there, sometimes by quotes and sometimes colorized. But now, hopefully it'll be clear to you what I'm talking about with the regular expression, because I can use syntax highlighting, and that's what I'm going to do for the rest of this discussion. Okay? Now, let's talk about the concept of meta characters. Okay? Look at this phrase: hit, hat, hot, him, hilt. Okay? And str extract all h dot t, and then look at the output: hit, hat, hot. Take a second to think, what do you think's going on there? Str extract all h dot t, hit, hat, hot. What's happening is that h dot t, the dot is kind of playing this this wildcard character, right? Match anything, match any single character. These things, meaning like the dot in this case, that character is called a meta character. A meta character is a character that has a non-literal interpretation. And there are lots of those. Here's a listing of just some of them that you will have to memorize. Now, don't get too afraid. This is actually pretty easy to memorize them once you kind of understand what they're used for and understand their pattern. But the basic idea is that some characters, when you express them in a string as a regular expression, like h period t, that period there is actually not playing the role of period. It's playing the role of a wildcard character, any character that is essentially not a not a space, okay? So that should make you think, actually, hold on. If period is a meta character and it's going to match any character, then how do you match a period? Okay? In other words, if dot is wild, how do you match a literal dot? Okay? This brings us to the notion of escaping a character. Okay? Escaping a character is achieved by putting a backslash in front of it. Okay, and the way that I usually like to think about this is that it's very much like your keyboard. Okay, there are many buttons on the keyboard in front of you if you're at a computer, and there is one special button, actually it's two of them, called Shift. And everybody knows that when you push the Shift button down and you hold that button, and you push another button, the other button that you push will have a different meaning. Okay, now you probably don't usually think about it as different meaning. You probably think about it as shifting the case of a particular character. Okay, but that is, in some sense, a different meaning, right? The button that was an A, and if you just ordinarily push it, would give you a lowercase a. Now, when you have the Shift button depressed, is going to give you an uppercase a different kind of character. That's what these slashes are going to do. If you put a backslash in front of a character, that backslash is going to toggle its meta-ness, okay? I don't know if that's a technical term, but it will be for our discussion here, okay? Putting a backslash in front of the character is going to change it, is going to toggle its meta-ness. So if it is meta, it's going to go literal on you. So the period is going to change from being meta by default to being not meta and matching a literal period. Or if it is literal, in the case of many of the letters, those are going to take on a special significance as being meta. Okay, and we're going to have to learn what those mean. Now, as a consequence, the backslash itself must be a meta character, right? If backslash is going to signify it's changing something else. In other words, it's not matching actually a backslash. It's going to change the character of the succeeding character. That means that the backslash itself must be meta. As a consequence, in R, when you're putting these into strings, you actually have to use two backslashes. So this is going to be one of the features that's kind of unique to R that's different from other regex engines, which is in R, usually when you're expressing a backslash, you're expressing it as two backslashes and not a single one. Okay, so let's see this escape character stuff in action. 1, 2, 3 space 1 period 3. Okay, 1, 2, 3, 123 space 1.3. Okay, str extract all 1.3. Notice that it pulls out the 1, 2, 3, the 123. That's because the period is matching any character, and a 2, of course, is a character. So it's pulling out the 1, 2, 323. What if you wanted it to pull out the 1.3? To do that, you would need to express the period as a literal character. To do that, you need to escape it so that instead of the period being meta, it will go literal on you. And to do that, you need to actually just put the backslashes in front of it. And of course, in R, there's two of them. So 1//.3, that slash is indicating that the period should be considered to be literal. And so it will match that. Another way to do this is actually to use something called a character class that we'll talk about in just a minute. But I'll show you it at this point. Inside of a character class, period is not meta. So I'll come back to that point too. But one way to signify this is 1 hard brace period hard brace 3. Okay, so now we're actually seeing 3 meta characters all at once. So these things come at you fast and furious. The hard braces are meta. They're signifying something other than just a hard brace, and we can achieve that same match a period literal using the hard braces. Okay. Now, before we actually get into that character classes, I want to talk about some special characters. As I said, putting the backslash in front of something is going to toggle its meta-ness, okay? If it's meta, it's going to go not meta. If it's not meta, it may go meta on you, okay? It's going to have a different significance. So how is this going to work? Well, a complete listing can be found in the help documentation of regex, which is actually part of base. So just do !regex and you're going to get a complete exhaustive listing of all of the things that are going to go meta on you. Let me just give you a few of the highlights. /in we actually met previously. /in indicates a new line, okay? So if you put /in in quotes, it may look like it's 2 characters, the slash and the in, but that's actually only 1, because that one character is signifying a new line, and that's 1 character. Tabs are /t. You'll see this a lot when you're reading in tab-separated values files. If you look at the actual text of those files in a sufficiently rich text editor, you'll see /t's everywhere. Those /t's are denoting tabs, which will vary in width depending on where they're being viewed. Okay. Now, on the topic of being viewed or printed, character strings, when they're actually printed, can look differently if these special characters are being kind of printed in their literal sense. So if /n is a new line, well, in a place like this, /n looks like /n. You can see it there. But when it's being printed, it should actually have a line break. Okay, that's the difference between like printing a character out, or printing a string out, and actually seeing the string kind of like natively. Okay, you could also think about it as a form of rendering. In any event, you can achieve this in a couple of ways. One way is using the cat function. The cat function does exactly what it does at the Linux command line, which is it will render or print out a string, okay? And when it does this, it actually interprets it. So when it sees the /n, it knows that that's a new line, and it actually puts that line break in here, and you get A, B. Another way to achieve this is with the write lines function, and sometimes you'll see people use that, okay? A tab is like this, and you can actually check if these are the same by passing in that string that we saw in the first example of A, new line B. Actually, we saw this example, in one of the last videos, and matching it to A, new line B, okay? And it says, oh yes, that was detected because there's a new line actually in that string, okay? Now, let's get on to the topic of character classes, which is really the first real regular expression we see. A character class is a single character regular expression. It's going to match any of a listed number of characters or their opposite, okay? In other words, it's kind of like something between a literal character and the period, which is going to match kind of any character. Well, sometimes you want to be more discerning than a specific character or absolutely any character. And a character class is going to give you that kind of intermediate behavior, okay? They're demarcated with hard brackets. So the hard brackets are meta because they indicate a character class, okay? So here's an example. The word gray in the English language is spelled with either an A or an E in front of the Y, okay? So if you want to match Gray Street, you could do it like this, str detect gr hard brace AEY, okay? What that's signifying is the third character of the string, so it's match first a G, then match an R, and that third character can be either an A or an E, okay? And that is precisely what happens, so str detect determines true there, followed by a Y, right? So gr, A or E, and then Y, okay? And it detects true there. Now, this also works if you have an E here, right? Because A or E, well, E is of course one of those, so it matches it. However, if you gave both of those, GRAEY, that no longer matches because the character class, remember, always matches exactly one character, okay? The character class will always only signify one character, okay? So if you have AE, even though both of those would individually be a match, they're not a single character. And so it's not GR and then one of those followed by a Y. It doesn't match that at all, and so it detects false here. Now, character classes don't demand that you enumerate all of the possible individual characters. There's some flexibility there. In particular, they support something called ranges. Ranges are going to be sequences of characters that are kind of baked into this system. And they generally go in a way that you anticipate, okay? Meaning the order of the characters is actually kind of a deeper order in the operating system, but it's going to follow your intuition pretty well, okay? So if I want to match any digit, meaning 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, I can do that using a character class that looks like this without actually typing those out, okay? So the character class followed by 0-9, the dash there is a meta character and it's signifying a range. So any character from 0 to 9, and those are in their natural order. So if you say, I have 3 kids, it will extract any single digit from that, and the digit that it pulls out is the 3 there, okay? Now, before, if you were following along closely, you will have noticed in that listing of characters that I said was meta, that dash was not meta. And that's because the rules for meta-ness actually change inside character classes, okay? Now, this sounds like it's going to be a big deal and a huge complexifier, but it turns out that it does almost nothing, okay? You don't have to like learn regular expressions all over again. It's just some things behave a little bit differently in character classes, and the dash and the dot, those are some of them, okay? What are these ranges, or kind of what's the extent of them? Okay, you can do 0-9 like this. The period is going to change as I showed you before. The caret at the beginning of a character class is going to negate the character class. So here I have that hat, het, hit, hot, and so on. Here, look at the character class. The caret here inside the character class at the beginning is going to signify not one of these characters, any of the others, okay, but not those, the kind of complement of those. So A, I, U, and now it's going to match E and O, the other vowels that you see there, okay? Now, outside of a character class, the caret is still meta, but it has a different significance. Its significance is not negate, its significance is as a line anchor, and we're going to see that in just a little bit, okay? Now, some character classes are so common for you to type them in that there's actually a shorthand version, so you don't have to even type in the character class, okay? These are called quick character classes, okay? And there are kind of a handful of them depending on what you want to do, but I'll say that the most common ones are the ones that you see right in front of you, okay? So /D, well, what is that? /D is going to take D from being a literal D, so now it's a meta D, okay? And the meta D is going to signify a single digit. So instead of typing in hard brace 0-9 hard brace, you can actually just you can type in /D, and it will be as if you have put this in everywhere. If you wanted to negate it, do the capital version. So /D is any digit, /D, anything but a digit, okay? Word characters, and I'm realizing actually there is something wrong in this example. A word character is a character that is any of these characters or an underscore. So this should probably come here at the end after the capital Z. There should be an underscore there. A word character matches an underscore as well. You should think kind of any character that could be used to construct the name of a variable in the R language, not in the non-syntactic sense. So in the ordinary naming conventions of R is going to be a word character. Okay, so /W is very, very common to see. It is largely going to remove you from things like punctuation or white spaces, okay? On the topic of white spaces match either a space, which is kind of like an invisible looking character there, but it is a legitimate character. A /N, as I said before, that is a single character, and here that's going to match a new line, so that's meta there too. /T or /R. /R is a carriage return. That's actually, when you think about a carriage return, it sounds a little bit like a new line. Think about it more like a typewriter, where in the old typewriters, you would type something, you would go to the end of the line, and then you would press the carriage return, and all that does is goes back to the beginning of the line, but it doesn't actually turn the drum, so it sends you back to the beginning of the line that you're currently on, okay? So in R, and another regular expression as well, /R is going to match one of these carriage returns. It's going to go back to the beginning of the line. So that's how progress bars work. For example. So it'll go back to the beginning of the line, it'll rewrite the whole line with white space, and then it'll rewrite it with whatever the progress bar, the text-based progress bar is up to that point, and it just kind of iterates that process over and over and over again, okay? So /S is going to match any white space, okay? Now, remember, in R, when you're putting in backslashes, you got to do the double thing, right? So instead of just /D, it's /D, right? Instead of /W, it's /W, okay? That's a very, very common thing. All right, let's see some examples. So here is a character vector. The office phone number is 254-710-6102. Call this for the office assistant, okay? If you wanted to actually extract those, we know that you would do lines str extract all, but now you're going to put in these digits. So the format of those phone numbers is /D/D/D. In other words, number dash, or maybe I should say digit. Digit /digit, okay? And that happens once in each of those. And so we get back a character vector stored as a list here because there could have potentially been more in each of those strings, okay? So this is our first real example of having a pattern that we want to match, not knowing what that pattern looks like, and extracting it in a meaningful way at the beginning. Now, I'm going to skip over something called POSIX classes and some Unicode properties. But I do want to say one thing about them, and that is that there are other flexible ways to refer to characters kind of a particular type, almost in the same way that the character class does. And POSIX classes, they're not totally portable, meaning that they may not work on some operating systems, but they're generally pretty well supported, okay? And they'll give you a way to express other kinds of character classes, maybe not so quick, but in a pretty flexible way. Along the same lines, Unicode is a encoding standard that allows you to put in richer characters than just A, B, or F. So this would support things like emojis and glyphs or symbols in other languages, or maybe accents on Latin characters. Those symbols can actually be characterized by properties that they have, which is actually inherent in the Unicode system. And to do this, you can refer to those kinds of properties with a p block, okay? I'm not going to go into this any further. I'll just say that the Unicode system is actually quite a bit richer than the regular system. You're usually dealing with characters that are encoded in Unicode. And so you can pull out or extract, or just generally refer to as regular expressions, different properties of characters using their Unicode properties. And I'll put tables here that you can reference a little bit later. Obviously, these are quite detailed if you want to refer to them, and those are the Unicode properties. Now, let me go back to these quick character classes for a moment, because there's something important that we kind of jumped over, and you probably thought that's pretty strange, okay? And that is, do we really have to go in here and type in /d/d/d dash? Isn't there a more elegant way to resolve that problem? And the answer is yes, and it comes in the form of so-called quantifiers. So here we're going to get our next 5 meta characters, okay? And these are all characters that are going to say repeat the previous pattern a certain number of times, okay? And so let's just kind of see how this works on an example. Here's the string BB space BAB space BAAB space BAAAB, okay? I don't remember where I got that example, maybe from the cheat sheet. In any event, it's a useful one, okay? Let's see how this works. A followed by a question mark says the character here may be an A, but it may not be there at all, okay? So it match either 0 or 1 A's, okay? If I say string str extract all BA question mark, that question mark is not literal. It's saying something about the number of times you match an A. So what does it do? It matches this B followed by nothing, okay? It matches this B followed by nothing. It matches this B and there's an A there, so it matches that one too. It matches this B, nothing follows it, match it, right? It doesn't match the space, it matches this B, it matches this B, but not the following thing, and so on, okay? Let's look at the star. The star says match 0 or more of them. So not 0 or 1, 0 or more, okay? So let's see what this matches. It matches this B, this B, this BA, this B, okay, nothing is really surprising there, space, this BAA, and that's where we get the first kind of interesting thing. There's an arbitrary number of A's that could follow the B, and it wants to match as many as possible, okay? Now, you can demand that it matches at least 1, okay? So if I say BA plus, that's going to say match a B followed by 1 or more A's, okay? So that's different than what we saw before, because before it might not match at all. So what does it match? It matches this BA, it matches this BAA, and it matches this BAAA. BAAA, okay, good. Now, so that's very flexible, okay? If you want to specify a certain number of times that the thing is going to be matched, you need to start using the curly braces, okay? The curly braces can be used in 3 ways. So A followed by parentheses followed by some integer, so the integer here, 5 or 10 or whatever, match exactly that many A's, okay? If you put a comma after it, it's saying match at least that many A's, but there could be more. So here's the match exactly 2 A's, and there's 2 instances of that. There's this one, and then there's this one that terminates. It doesn't get that last A there, okay? If you do at least, now it's going to get that last A, and if you want to actually bound how many A's could be there, you would give it an initial number and a terminating number. So N and M match between N and M different A's, okay? So that's your 5 other meta characters here. Question mark means 0, 1, times means 0 or more, so any number, plus means 1 or more, and then the curly braces are used as quantifiers. Okay, now, how would we simplify this kind of gross regular expression that we have here in the middle? And the solution, of course, is with quantifiers, and this is what it would look like. / d followed by 3, / d followed by 3, and 4, and so on, okay? And it pulls it out, and it's much, much cleaner to see what that would look like. Here's an example using this for email scraping. As you know, every web page is actually a rendered collection of HTML that can be viewed if you view the source. This is the webpage of the Department of Statistical Science here at Baylor, and it has email addresses of each of the faculty members actually on the webpage. Now, it actually has them in 2 ways. One, it presents them here, but if you looked at the source code of the webpage, you would also see that it provides a hyperlink, and the hyperlink duplicates that. So it refers to it again. In other words, for each individual in the actual source of the webpage, you would see their email address at least 2 times, one being what is actually printed and one being the hyperlink, okay? You can view the source in any browser by going to something in the options like view source or develop or show source, something like that. Okay, and when you do that, you'll see that that this information is there. Okay, now these HTML web pages are very difficult to look at as a person. Computers have no problem with it, but as a person, it's more challenging. But I have done this work for you. You can actually see that I searched for James Stamey, and you can see here is his name, and his email address is right here. So mail to James_Stamey at Baylor.edu, and then there it is again. This is the printed part, and this is the hyperlink part, okay? And it's like this for all the faculty. So let's say that we wanted to go into this web page and we wanted to scrape out all of the email addresses. Well, I can do this using read lines. This is kind of a crude way to do this, but it certainly works. So read lines, I give it the URL for the web page, and it gives it back to me as a string of almost 2,000 lines long. So this is actually the web page that we were looking at before. I've showed the first 25 lines here, and it's exactly like the view source part of the web page. Okay, so all of it just as a sequence of strings, so a character vector of length almost 2,000. Okay, now I'll say str extract all, some number of one or more word characters, followed by the @ symbol, followed by Baylor, followed by period, followed .edu, and then I'll flatten that and I'll pull out all the unique ones. And now I have all of the email addresses of all of the faculty on that web page. So these tools, these regular expression tools, can be very, very powerful when combined with just simple read lines to pull things off of the internet and to kind of do basic scraping here. Okay, we don't talk about it in this video, but the two R packages that are kind of tidyverse adjacent, called Hitter or HTTR and Arvest, like harvest with R, are used to scrape web pages in a more flexible way. Okay. Now, with that out of the way, we can talk about groups. Groups are achieved by using the meta characters open and close parentheses, and they're going to group collections of characters together to act as a single unit. Okay, so be careful. We talked about character classes before, but character classes are just for an individual character. Okay, groups will allow you to express what will be alternatives in a little bit as a collection of characters, not just one. Okay, so let's look at an example. Here's a character vector of strings LD, LED, LAD, LEAD. Okay. Now, if I want to match the idea of match an E followed by an E or an A followed by a D, that's what's achieved with a character class. And that's matched by LED and LAD, like right there. Okay. Now, what if I wanted to match L followed by either nothing or an EA, like both of those in a D? That is what is achieved by a group. Okay. A group and a quantifier. So L group EA, and that group could either be wholly there or wholly gone, right? That's the quantifier question mark, and that gets kind of the opposite of this. So it matches LD, it does not match LED, LAD, but it does LEAD, okay? And there are kind of other permutations of this that you can tell, oh, the grouping is actually doing something meaningfully different. Now, groups are often used with a concept called alternation. It's very common when you're processing strings to want to match alternatives that are a sequence of characters, right? So the pattern looks like this, or it's going to look like that, or it's going to look like something else, okay? The meta character of the pipe expresses this notion of or, and it's usually used inside of a grouping arrangement, okay? Now, you may think to yourself, well, the character classes are also kind of giving you a sense of orness, right? Disjunctive, this or that, okay? However, they only do it for an individual character. The pipe with grouping is going to allow you to do it for many different characters, okay? So here's a string, I feel happy today, okay? And I want to pull out whatever the emotion is, but the emotion could either be sad, happy, angry, or surprised. And it pulls out HAPPY, so a sequence of characters, not just one, okay? I could actually tie this into a list of emotions. So the regular expression doesn't have to be typed directly into the function str extract all. It can be actually bound to a variable and then found that way, and that's just fine. Glue is actually very, very powerful for creating regular expressions. So let's look at an example of that. It's very common for people to try to obfuscate their email addresses when they put them on web pages by doing things like this. foo@bar.io, okay, where the AT, if you're a person, you look at that and you say, oh, that's the @ symbol. But if you're a computer and the computer is just trained to look for something at symbol something dot something, it may not find that. Okay, my claim is that actually that is quite simple to circumvent with regular expressions, and all you need to do is to create a regular expression that's sufficiently rich to express the idea that the email could be stored with any amount of white space on the side followed by the at symbol or AT. Okay, now I'm going to make everything lowercase in just a little bit so you'll see why that simplifies things. In any event, I'm calling that AT. So AT is a variable name, and it's containing this regular expression that is going to match the at part of a email address. The same thing with dot. So it could be DOT with any amount of white space on the side, or it could be a period. And the domains, that's the com part or edu part of an email address. That could be any of a number of different alternatives. The regular expression then is actually going to be quite a large regular expression, which is constituted of each of these little parts. And I'm going to use glue to achieve it. So how do I use glue? Any number of word characters followed by whatever you're using to achieve the at symbol, right? That's this variable right here. So inject that into that spot, followed by any word characters, the dot, and the domains, okay? So here is the ultimate regular expression that's going to match email addresses in this particular case, and it's going to pull out all of those when applied to these emails, okay? Now, you can actually replace these using the replacement functions by replacing any of the at things with an at symbol and any of the dots with a dot symbol, and that will kind of regularize them into a normal form, okay? Now, with that out of the way, we can talk about back referencing. Back referencing is going to provide a way to match things that have been previously matched, okay? The best example that I can think of for this is when you accidentally type the same thing in a text file, usually because you're editing it. So I kicked the ball, okay? The second "the" there is unintentional, okay? However, it kind of came along for the ride. How do you detect something like that? A word that is repeated 2 times. If you don't know in advance what the word is, you can actually do that with back referencing. And back referencing is going to use groups. So what you're going to do is you're going to use a group construct, and whenever that group is matched, it's actually going to get a number, and that number can be referenced by putting 2 slashes in front of whatever the match was. So this is the first group, so matching it twice. I kicked the ball, str extract all, some number of word characters, followed by a space, followed by the same match again, and it matches the. Okay? Now, you can do this to some limited extent using replacing. So if you wanted to replace this, you can actually put the reference there in the replace, and I've had some limited success with doing that, okay? Now, I'm going to skip this part because it involves word boundaries, and I want to talk about word boundaries actually in the next slide. So word boundaries are going to be meta characters. Actually, they're ordinary characters that are escaped into meta, to non-literal sense, and they're Bs, that are going to match the transition from white space to not, and vice versa, okay? And as I said, it's /B. So /B is a word boundary. It's going to match either white space going into text or text going into white space, okay? Let's see an example. This is a complicated example, but I think it's helpful for this particular concept. The Theo from Athens liked to tithe. Okay, the Theo from Athens liked to tithe. Okay, got it. If you say str view the, there's lots of instances of the in this particular string, right? There's the by itself, the at the beginning, the in the middle, and the at the end. Okay, that's why I picked this particular example. Now, if I want to match that the is at the beginning of a word, okay, that happens in 2 spots. It happens here and it happens here. But how would I communicate that idea of, no, it's the first 3 letters of a word, okay? To do that, I need to start it with a word boundary. So there's a word boundary followed by the, and that matches the here, and then the the at the beginning of the sentence, and then the th at the beginning of Theo. But it doesn't match the the in Athens or the the at the end of tithe, okay? To do that, I would need to put the word boundary either at the end, or if I want it to be the word itself, I would put a word boundary on both sides, okay? That means this is the word is the, okay, and it has to have white space on both sides. The capital B is not a word boundary. So if I wanted to match the the in Athens, I could do that by doing this / capital B. That would knock it off at the beginning. So it can't be a word boundary at the beginning, and then it's going to follow a the, so that either gets it in the middle or it gets it at the end, okay? Similar concept is line anchors. Line anchors, they're not going to match the beginning or the end of a word, they match the beginning or end of a line, okay? The caret matches the beginning of a line, the $ matches the end. so they're both meta, okay? Here's an example. A, B, C, D, E, if I say, show me the B happens here in the second position, okay? But if I say caret B, that's looking for the beginning of the line followed by a B, and that is not matched. Similarly, if I want the D, I would match just the D. If I want the D followed by the end of the line, the $sign is going to follow it at the end. A similar concept is lookarounds, okay? But it doesn't match positions. It's going to match relative positions, okay? Lookarounds are going to match before or after a pattern. I think the best example of this comes in greetings, like Dear David Kale, okay? So if you want to match just the name here and not the dear part, okay? It's very easy to match like dear followed by some name, but then it would pull the dear out with it, okay? So what I want to do is I want to match the name, or I want to extract the name, but I don't want to have the dear there, okay? So how would I do that? The general construction is to use a lookaround, and the lookaround takes either of two forms. Either you have a regular expression, so I'm going to call the undesired expression the nearby regex, and the one you want the desired regex, okay? So this would be an example where the regular expression that you want to match is preceded, or maybe I should say precedes the regular expression you don't want. So the desired regular expression, and then this construct is going to say that construct has to follow it, but I don't want that to be part of the regular expression that is extracted. The same thing happens with a preceding like this, okay? So always think about lookarounds like this. They're going to generally look like groups, but they're going to follow, so in other words, there's going to be parentheses, but immediately following the parentheses, there's a question mark and an equal sign. That's going to be kind of like the basic construct, okay? Group, question mark, equal sign, okay? Add a less than before the equal sign, meaning kind of like put a less than symbol in here, if you're using it to precede the thing that you want, okay? And change the equal sign to a bang if you want to negate it. So like it is not preceded by, or it does not follow, okay? That's the basic idea. Let's see an example. Here's the salutation, Dear David Kale. If I wanted to match anything that precedes the comma, I could say match any character followed by a comma, okay? Notice that when it actually does the extraction, that comma does not come along for the ride, okay? It's just Dear David Kale, okay? If I want to do it the other way around, everything that follows dear, space, okay, it would be question mark less than equal dear, D-E-A-R space, okay? So the D-E-A-R space, that's those, and match anything that comes after that. So David Kale, comma. You can also combine these to get just the name out, okay? So, and I kind of just nest these to do it. There's a few ways to do it, but this is the basic way. So D-E-A-R space, and then something that precedes a comma, okay? And then I have the name out of the salutation. The last thing that I want to say as part of this string lecture, which has been very long, is that there are tools online that can facilitate using regular expressions, and I strongly encourage you to do that. One of these is regex101.com, where you can go and you can type in the regular expression you want and give it a test string, and it's going to use really great syntax highlighting to show you what the regular expressions are that would be matched by that particular regular expression. So this is just a tool to kind of facilitate the creation and the testing of regular expressions. It's very common when you write regular expressions that you'll write a regular expression that matches what you want, but it'll kind of match some other things that you didn't quite want. And usually it's an iterative process. And these are tools that can help you really target your regular expressions to get exactly what you want.